This is a mini tutorial on solving an absolute value equation. So I'm going to begin here with a really basic absolute value equation here, and it says the absolute value of x equals 6. So based on your knowledge of absolute value, we know that we should get two solutions here because there are two numbers that would satisfy this equation. I can either plug in 6 into this absolute value and still get the absolute value of 6 equaling 6, or I can plug in the absolute value of -6 and get 6 as well. So we're going to apply that idea here when we solve for a little bit more complex equation, like in number 2. Before we can set up our two equations though, and this is the part where some students make a mistake, you always have to isolate the bars first. So we have to get the bars alone before we can set up our two equations. So based off of what we just talked about over here, I know that x minus 4 could equal positive 4, right? The inside of this could equal 4, but I could also place inside there a -4 and I would still get the absolute value equaling 4. So I'm going to set up an additional equation that x minus 4 equals -4. So I get two unique solutions here, x equals 8 and x equals 0. So a lot of times students have a tendency to solve for 1 and then they'll just put plus or -8 in front of the number. That is not correct. So over here we did get plus and minus 6, but here when the equation becomes a little bit more complex, you don't want to do that. Okay, now in problem number 3 here, this again, you want to isolate the bars here. So let's get the bars by themselves before we can set up our two equations, and we end up with the absolute value of x minus 4 equaling -4. So obviously I purposely did a pretty similar equation over here, but the fact that there is now this negative sign here completely changes what we're going to do. So recall that absolute value makes everything on the inside positive, right? So after you take the absolute value of something, your result should always be a positive number. So really, no matter what I try to plug in here, even if it's 8, if I take the absolute value of 8 minus 4, I get 4, right? This is never going to allow me to equal a negative number because the absolute value can never equal a negative number. So this here has no solution. Now you want to be careful though that you don't try to do everything as no solution. And you want to look for that before you try to set up your two equations, okay? Because you will still get two actual answers, but they won't work back in your original equation. So for example, let's say I look at this and I don't see anything weird about it at all yet. So I'm trying to isolate the bars and I subtract that 5 first, and then I divide out the 2 and I get an equation that looks like this, and I go ahead and I set up my two cases even though I have a negative here. I'm not realizing it yet, so I get two cases and I solve each one. So if I added the 3 here, I get a positive 2. If I add the 3 here, I get a 4. So I would be like, oh yeah, I got my answers. You need to make sure that you test your answer back in your original problem. If I try to test these answers back in here, 2 times the absolute value of 4 minus 3 plus 5 is going to equal, so 2 times the absolute value of 1, which is 1, plus 5 is going to equal 7. Obviously not the 3 that I had originally, so that 4 doesn't work. It's an extraneous solution. If I try 2, I plug this in, I still get 2 times the absolute value of -1, which is 1, so 2 times 1 plus 5 is also 7. And so nothing here works. Even the two solutions that I found don't work because, again, it goes back to this idea. Oops, not in that step actually. It's in this step here. When you have the absolute value bars by themselves equaling a negative number, this is not possible. So you don't want to overdo that, because in this next example, number 5, it kind of looks like we should have a no solution here because you see this negative sign over here. But remember, you always have to isolate the bars. You have to get these by themselves first before you analyze your equation. So we'll subtract the 2 first, and we have the absolute value times -3, so -3 times the absolute value of x minus 4 equaling -6. Now once we divide out that -3, we actually end up with a positive 2. So this does have solutions. In this case, I want to set up my two cases, x minus 4 equals 2 and x minus 4 equaling -2. So I go ahead and I solve, and I get two unique solutions again. Okay, that's the end of this little mini tutorial.